Today is Monday, April 20th, and we are going to be working through a rock lab for the next 3 days. So if you look at this little chart down here, we have 15 different rock samples that we're going to be identifying as igneous, metamorphic, or sedimentary rocks. You have had 3 separate labs in the past week going over igneous, sedimentary, and metamorphic labs individually. Okay, they were all grouped together. Now they're jumbled and you're going to have to decide. So some really important facts. First thing, watch this whole video. Okay, it's going to be your instructions for the next 3 days. Second thing, actually read the instructions here in the left-hand column. They will help you. If you don't, go back and look at them because they will help you. Third, down here at the bottom, next to the magnifying glass, there is a video. Click on it and watch it to the end. Actually watch it because it will help you complete this lab. Okay, on our team's assignment here, if you guys take a look, we want to make sure we read all the instructions. It helps if I maybe spell instructions right. Ha. And then you're going to have a rock identification lab to fill out and a identifying chart to help you with it. Okay, so this is the virtual website. It will be linked to our assignment. This is our rock lab. I have 5 igneous rocks, 5 sedimentary rocks, and 5 metamorphic rocks. There are also these are the data tables that we used for identification for our previous 3 labs. I just attached the identification charts themselves. So the top one is for igneous, goes over fine grain, coarse grain, goes over the composition. Felsic means light in color, mafic means dark in color, and intermediate is a mix. Okay. The sedimentary rocks go over the texture of a rock. If it's organic, meaning land dry, inorganic, sorry, so it's not made from reused materials. Chemically or organically formed means the remains of other things. It goes through the grain sizes, what they look like, tells you a little bit about the chemicals found in them or special reactions they might have. Sorry, I had you on. And then the third is metamorphic. Metamorphism increases. There are foliated and non-foliated textures for metamorphic rock. They go through and change the grain size. They can have specific things to identify them. Interlocking grains, very, very smooth. They break easily along certain surfaces, that kind of thing. So these 3 charts you're already familiar with, you're going to use to help you fill out this information here. And I have some information typed already, but I am going to get rid of that so we can fill it out together. So, I had to make sure the lab worked before I made you guys do it. All right, so back to our actual assignment here. I am going to choose a rock, any rock from this table. Okay, I am going to go for this guy right here. Put it on here. I have 3 different options. I can go over igneous rock testing, metamorphic rock testing, or sedimentary rock testing. Based on the way this looks, I feel like I've seen a rock similar to this, and I'm going to take a guess saying that it's an igneous rock. I click on this. All right, it looks like it was an igneous rock because it let me open the door. If I were to go back and try to take a set, there you go. So none of the metamorphic rocks would let me test because this rock is not metamorphic. Okay, so I have 3 different things I am looking for specifically. The color of the igneous rock, the texture of intrusive or extrusive. Intrusive means it formed inside the earth. Extrusive means it formed outside of the earth. Remember, igneous rocks are rocks created from lava or magma. Okay, so let's look at the color first. Igneous rocks can be categorized as light, intermediate, or dark. Light colored igneous rocks are classified as granitic. Intermediate colored rocks are andesitic, and dark colored rocks are basaltic. So this shows you here a comparison: light, intermediate, or dark. Okay. What do you think for this sample? I would say it's probably pretty intermediate. Okay. So I'm going to go back to my rock color on this chart. Actually, I just realized I didn't write down what number my rock is. So this would be, these are 1 to 5. This would be 6 to 10, 11, 12. This is rock sample 12. So I'm going to click over here. Sample 12. The color would be intermediate. What else? What other option did we just see? Going up here. Andesitic. Andesitic. All right. Was it intrusive or extrusive? Well, we haven't figured that part out yet. So, based on the size of the crystals, I feel like the texture of extrusive rocks is going to be more like the lava rocks we see around here in Idaho. They'd have a lot more pores and holes and stuff in them. So I'm going to guess it's intrusive. So igneous rocks can be classified by the size of their crystals that form as the molten material cools. When magma cools slowly deep inside the earth, the igneous rocks that form are coarse-grained. Slow magma enables them to migrate and form large crystals. So, if I look at this guy, it looks really similar to me, to the picture we looked at from the original form of the rock. So I'm going to go ahead and close this guy out. I'm going to say that we are an intrusive rock with large crystals. So going back to our data table, this would be intrusive. There were no holes in the rock, and it was coarse-grained. I don't know why that font's different. Weird. All right, so if I wanted to read a little bit more about extrusive, it would show me lava that cools quickly near the earth or on the surface, form things that are fine-grained, and they have a glassy appearance. Okay, sometimes the gases can get trapped and make holes. Okay, so those are things we're all familiar with. We're gonna go back to the main lab. Now, I can't test in metamorphic or sedimentary. I know this has to be a type of igneous rock. So I click on this guy. I have slate, shale, scoria, sandstone, rock salt, quartzite, pumice, obsidian, mica schist, marble, limestone, granite, gneiss, conglomerate, and basalt. This is in a list of all 15 of those rocks. Okay, based on what I know, going back to our little igneous data table, if my rock is intermediate in color, okay, and it is considered coarse-grained, I need to figure out a rock that could have formed like this. I'm going to go ahead and take a guess. I am pretty sure that this is a type of granite. I'm going to click check, and I got it correct. So going back to my rock lab, I'm going to type over here, granite. And I am done with my igneous rock for the day. Okay. Did not mean to click on sedimentary. All right. Now I'm going to choose another rock here. We'll go for another speckled one. This guy, to me, looks very morphed. Do you guys see how it has lines or it's almost foliated? Do you guys remember? So the term foliated throws us back into metamorphic. Oh, and my guess was correct. All right, real quick, what rock sample was this? This is rock sample 4. All right, so going to my lab over here. We are in metamorphic rocks, rock number 4. Okay. Now, we're looking for banding in metamorphic rocks if there's recrystallization or there's hardness of a metamorphic rock. So, metamorphic rocks are formed when rocks beneath Earth's surface are subjected to great pressure from overlying rock layers or increases in heat. Sometimes the pressure will flatten and align material or mineral grains within rocks into parallel bands. Banding, no banding. I'm going to say this guy has banding. To me, that looks like banding. All right, so going back to this guy here, I'm going to say yes to banding. Is there recrystallization, big crystals or no crystals? So let's look at recrystallization. As mineral grains are flattened in a line, they can also exchange ions with surrounding minerals, forming new or bigger crystals. This process of mineral grains changing composition and growing larger is called recrystallization. Some recrystallization occurs in minerals that are realigned. In metamorphic rocks composed of only one mineral, however, recrystallization is the only process observed. These are crystals. Okay, so looking at this guy here, there could be some crystals. I'm not sure how many though, or what would quantify that. So I'm going to say recrystallization. Okay, now we need to know hardness. Is it scratch glass or not? And then is it considered big, medium, or small grained? All right, so it looks like it scratches the glass. So hardness is useful for characterizing or classifying minerals such as quartzite and marble that contain only one mineral. One way the hardness of a rock can be tested is by dragging the rock across the surface of a piece of glass. Rock that are harder than glass will scratch the glass. Rocks that are softer will not. So this rock is obviously harder than glass. So looking back at our chart here, do any of these scratch glass? Does not specifically say in our metamorphic chart. We do have slate, phyllite, schist, gneiss, marble, quartzite, and anthracite to choose from. Going back over to our lab, it does scratch glass. We need to figure out its grain size. Was it big, medium, or small? So looking back, let's grab the magnifying glass. All right, and I would say this is medium. I don't see really big ones, but I don't see really small ones. So we're going to say medium. And we need to choose a rock name. So remember this list over here that we have. We've got slate, phyllite, schist, gneiss, marble, quartzite, or anthracite. I said that ours was foliated and medium to coarse grained. I'm going to guess it's going to be a schist or a gneiss. Let's see what we have on the list. Goodness, sorry. Click this guy here. Slate, shale, scoria, sandstone, quartzite, pumice, obsidian, mica schist, marble, limestone, granite, gneiss, conglomerate, or basalt. So it's either gneiss or mica schist. Let's go back and look at this list here. And it could be gneiss or schist. So is it darker in color, looks more like this guy, or is it lighter in color, looks more like this? Let's try the mica schist first. That's what I'm going to go with. And let's see if we're right. Da, da, da. Oh, I was wrong. All right, let's try gneiss. There we go. That's a lot nicer. Huh. All right. So you're going to go back to our list and you're going to write next to number 4, gneiss. G-N-I-S-S. Or sorry, G-N-E-I-S-S. So if you click on the doors on accident, it will continually talk to you. All right, the third and final sample that you are going to go over for the day, I'm going to try to do a different one. Let's see. To me, this looks like a bunch of rocks stuck together, so that means it's not igneous or metamorphic because the rocks already had to be created before they could be glued together. So it's going to be sedimentary. All right, so sedimentary rock. My goodness, I keep doing this. It is rock sample number 14. So go back over to our rock identification chart. This is rock sample 14. All right, so we're looking for sediment types inside a sedimentary rock. We're looking for the size of sedimentary rocks, and we're looking for carbonate materials in sedimentary rocks, okay? So types of sediment and sedimentary rocks. Sedimentary rocks are formed when loose materials called sediments become pressed together by compaction and or cementation. Types of sediments found in these sedimentary rocks are salt, sand, mud, gravel, and fossils. This guy definitely has gravel, maybe a little bit of mud and sand. All right, so looking back at our chart here to make sure we're doing the right thing, types of sediment. I'm going to say mud, rocks, maybe a little bit of sand. Okay, the size of the sediment. Let's see. Sedimentary rocks can be classified by the size of sediment found in them. The following classifications can be used to describe sediment. Microscopes, or so, obviously we can see rocks in this without a microscope. Okay. Does it look smooth like flour under magnification? Does it have grains of sand? Is it visible to the naked eye? This guy obviously has large size sediment. So going back over here, I'm going to put large. React to HCl. So HCl is hydrochloric acid. This is one of my favorite labs that I would love to do with you in person. Okay, but unfortunately, circumstances, you just get to see the video simulation of it. So carbonate materials are materials that are repurposed. So if there's fossils that are pressed together into a rock, they make a carbonate material, because remember, when radioactive decay occurs, we break down things in the body, there is a carbon footprint left, and that carbon reacts with hydrochloric acid, and it makes a fizzy, bubbly sound. Okay, so sedimentary rocks can be classified by the type of mineral they contain. Rocks containing carbonate materials, such as calcite, will react with hydrochloric acid. So do you see that bubbly foam color? It kind of looks like someone spit. It's kind of gross. But they normally bubble like that, and they make a small, like, hissing noise. So to test, we're going to use some of the HCl with the eyedropper and place a few drops of acid on the rock to make sure that it doesn't have carbonate in the material. If it bubbles, then it does. If it does not bubble, then it's not. So we're going to click on this guy. I don't see any bubbling, and I don't see any hissing or hear any hissing noises. That means it is not a carbonate material. So going back to our lab, we're going to click over here, and that is a no. So looking at our sedimentary rock list, okay, we've got clastic or clastic is a texture. We have got inorganic or organic. I'm going to say ours is not organic, because organic would be able to react to the calcite. Okay, so we are looking for something like conglomerate, breccia, sandstone, shale, or siltstone. Okay, this kind of gives you some symbols of it. Are there pebbles and cobblers or boulders? Is there sand, silt, or clay? I'm going to say the grain size is pebbles or cobblers. It contains minerals or fragments of other rocks and minerals. Are they rounded fragments, angular fragments, fine or coarse? I'm going to say ours are rounded, so my guess is going to be a conglomerate type of rock. If we go back to our actual lab, enter through the main door, and we look at the list, let's see, we've got basalt, conglomerate, granite, limestone, marble, mica, schist, obsidian, pumice, quartzite, rock salt, sandstone, scoria, shale, and slate. I'm going to try conglomerate, see how we do. I was correct, so going back to my lab, I'm typing in conglomerate. All right, so I have officially done my 3 rocks for the day. That is all I am requiring of you to do based on my instructions here. Okay, you're doing the first 3 rocks going from left to right. If you have similar rocks to me, that is fine. You are welcome to do the same rock. You are also welcome to try to do it on your own. I obviously gave you 3 examples. That's 3 of the 15 rocks that you already have the answer to. Okay. Please, please, please reach out, contact me if you have troubles or issues. Again, we're completing this lab Monday today, Tuesday tomorrow, and Thursday. There is no work on Wednesday anymore. You are going to be taking your time to identify this lab the best you can. And again, please reach out if you need help. Have a great Monday, and let me know if you have questions. Bye, guys.